Hey crew, it's Pitt and I'm back with some more philosophy. Today we're diving back into the works of Georg Hegel. This is The Science of Logic. We are reading aloud and discussing as we go along the various points that are brought to light by the text. It is not the format for everyone, but people find value in it, so you are more than welcome to tag along as we continue our exploration. Before we begin, however, if you are unfamiliar with me, any of my unconventional beliefs, or if at any point in time I lose you in terminology, there will be several playlists linked in the corner above, in the box down below, along with the original source material, so that you can get a better understanding of who I am and why I say the things that I do. With that being said, let us dive in and continue our exploration of the science of logic with Part 2, Chapter 2, Real Measure. Measure is now determined as a connection of measures that make up the quality of distinct, self-subsisting somethings, or, in the more common language, things. The relations of measures just considered belongs to abstract qualities like space and time. Further examples of these, now to be considered, are specific gravity and then chemical properties. That is, determinations of concrete material existence. Space and time are also moments of these measures, but are now subordinated to other determinations, and no longer behave relative to one another only according to their own conceptual determination. In the case of sound, for instance, the time within which a certain number of vibrations occur, the spatial width and thickness of the sounding body, are moments of its determination. But the magnitudes of such idealized moments are externally determined. They no longer assume the form of a ratio of powers, but relate in the usual direct way, and harmony is reduced to the strictly external simplicity of numbers and relations which are most easy to grasp. They therefore afford a satisfaction which is the exclusive reserve of the senses, for there is nothing there of representation, imagery, thought, or the like that would satisfy spirit. Since the sides which now constitute the relation of measure are themselves measures, but are at the same time real somethings, their measures are, in the first instance, immediate measures, and the relations in them direct relations. We now have to examine the further determinations of the relations of such relations. Measure, now real measure, is as follows. First, it is the independent measure of a type of body, a measure which relates to other measures, and, in thus relating to them, specifies them as well as their self-subsistent materiality. This specification, as an external connecting reference to many others in general, produces other relations, and consequently other measures. The specific self-subsistence, for its part, does not remain fixed in one direct relation, but passes over into specific determinacies, and this is a series of measures. Second, the direct relations that thus result are in themselves determinate and exclusive measures, elective affinities, but because they are at the same time only quantitatively different from one another, what we have is a progression of relations which is in part merely external, but is also interrupted by qualitative relations, forming a nodal line of specifically self-subsisting things. Third, what emerges in this progression for measure, however, is the measureless. The measureless in general, and more specifically the infinitude of measure in which the mutually exclusive forms of self-subsistence are one with each other, and anything self-subsistent comes to stand in negative reference to itself. A. The relation of independent measures. By measures, we no longer mean, now, merely immediate measures, but measures that are self-subsistent because they become, within themselves, relations which are specified, and in this, being for itself, they are thus a something, things that are physical and at first material. A. However, the whole, which is a relation of such measures, is at first itself immediate. Thus, the two sides, which are as such independent measures, have their subsistence in things external to each other, and are posited in combination externally. But the self-subsistent materialities are what they qualitatively are only in virtue of the quantitative determination that they have as measures, and are posited in virtue of this same quantitative connection with others as non-indifferent from them, the so-called affinity. They are the members of a series of such quantitative relations. This indifferent multifarious relating concludes at the same time by cutting itself off as an exclusive being for itself, the so-called elective affinity. A. Combination of two measures. As a measure relation, something is in itself determined by quanta to which further qualities accrue. The something is the connection of such qualities. One of them is the something's in itselfness, according to which it is something that exists for itself, something material, a weight, if taken intensively, or taken extensively, an aggregate of parts. The other is, however, the externality of this itselfness, something abstract and idealized, space. These qualities are quantitatively determined, and their mutual relation is what constitutes the qualitative nature of the material something, the ratio of weight to volume, the specifically determined gravity. The volume, the idealized element, is the one to be taken as a unit, whereas the intensive aspect, which in quantitative determinateness and in comparison with the other appears as extensive magnitude, that is, an aggregate of ones existing for themselves, is the amount. The purely qualitative relating of the two determinacies of magnitude in a ratio of powers has disappeared. Because with the self-subsistence of the being for itself, the material being, immediacy has come back, and in this immediacy the determinateness of magnitude is a quantum whose relation to the other side is likewise determined in the ordinary exponent of a direct ratio. This exponent is the specific quantum of the something, but it is an immediate quantum, and this is determined, as is also the specific nature of the something, only in being compared with other exponents of like ratios. The exponent constitutes the specific way in which the something is determined in itself, the inner measure characteristic of it. But since this, the something's measure, rests on a quantum, it is also an external and indifferent determinateness, and the something, despite the inner determination as measure, it is for this reason subject to alteration. The other to which it can relate as alterable is not an aggregate of matters, not a quantum in general. On the contrary, against these it holds out its specific intrinsic determination of being. Rather, it is a quantum which is at the same time, it too, the exponent of such a specific ratio. Take two things of different inner measure that stand connected and enter into composition, say two metals of different specific gravity. In what way the two must otherwise be homogeneous in nature in order for the composition to be possible, e.g., that we cannot be speaking here of a metal combining with water, this is not at issue here. Now, on the one hand, each of these two measures preserves itself in the alteration they will incur because of the externality of the quantum, but each is a measure, for each is a measure, but on the other hand, this self-preservation is itself a negative relating to the quantum, a specification of it, and since this quantum is the exponent of the ratio of measure, the self-preservation is an alteration of the measure itself, and indeed a reciprocal specification. According to its merely quantitative determination, the compound would be a mere sum of the two magnitudes of the one quality and the two magnitudes of the other quality, e.g., the sum of the two weights and the two volumes in a compound of two matters of different specific weights, so that not only would the weight of the mixture remain equal to the said sum, but also the space which the mixture occupies would remain equal to the sum of the two spaces. But only the weight of the mixture is found to be in fact the sum of the weights present prior to combination. The side capable of addition is the one which, as the one existing for itself, has attained stability of being and consequently a permanent immediate quantum. The weight of matter, or what amounts to the same thing from a quantitative standpoint, the aggregate of material parts. Alteration falls instead in the exponents, for they are the expression of the qualitative side of the compound, of its being for itself as relations of measure, and since the quantum as such is subject to accidental alteration by an increase which is summed, this being for itself proves at the same time to be a negating factor with respect to this externality. Since this immanent determining of the quantitative element cannot appear, as we have seen, in the weight, it turns up in the other quality, which is idealized side of the relation. It might be surprising to sense perception that, upon the mixing of the two specifically diverse materials, what results is an alteration of the total volume. Normally, a diminution of it, for it is space which gives stability to matters otherwise existing outside one another. But this stability, in face of the negativity which is in the being for itself, is that which has no existence in itself, is the alterable as such. In this manner, space is posited as what it is in truth, an idealization. But then, not only is one of the qualitative sides posited as alterable, but measure itself, and so also the qualitative determinateness of the something which is based on it, has shown itself not to be something stable within, but, like quantum in general, to have its determinateness in other measure relations. B. The measure as a series of measure relations. 1. If something united with an other were what it is only by virtue of simple qualitative determination, and the same also applied to the other, then the two would only sublate themselves in being compounded. But when something is in itself a measure relation, it is independent, yet at the same time capable of union with another, which is also in itself a measure relation. 4. In being sublated in union, each preserves itself through the permanence of its quantitative indifference, and it behaves as the specifying moment of a new measure relation. Its quality is enveloped in the quantitative element. It is therefore equally indifferent towards the other measure, continuing in it and in the newly formed measure. The exponent of the new measure is itself only some quantum or other, an external determinateness, and its indifference is displayed by the fact that the specifically determined something runs, with other such measures, into precisely the same kind of neutralizations of reciprocal measure relations. The specific property of the something is not expressed in the one measure relation alone, which is formed by it and another something. 2. This combination, with a plurality of others which are in themselves likewise measures, yields different ratios that therefore have different exponents. The measure which is independent has the exponent of its being determined in itself only in the comparison with other measures. Neutrality with the other constitutes, however, in its real comparison with them, it is its comparison with them through itself. The exponents of these ratios are, however, diverse, and the independent measure consequently displays its qualitative exponent as the series of these different amounts of which it is the unit, a series of specific ways of relating to others. As one immediate quantum, the qualitative exponent expresses one single relation. The independent measure truly differentiates itself in the characteristic series of exponents which it, taken as a unit, forms with other equally independent measures. For each of these measures, also brought in connection with any other and taken as a unit, forms a series. The relation of such series among themselves now constitutes the qualitative aspect of the independent measure. Now, inasmuch as this independent measure produces a series of exponents with a series of such independent measures, it appears, at first, when compared with another independent measure outside this series itself, that it is differentiated from it by virtue of the fact that this other independent measure produces another series of exponents with the same measures opposite to it. But in this way, the two independent measures would not be comparable, not insofar as each is regarded as a unit with respect to its exponents. And the two series, thus resulting on the basis of this connection of unit and exponents, do not differ in any determinate way. The two measures, which, as independent, are supposed to be compared, are at first differentiated from each other only as a quanta, in order that their ratio be determined. The ratio requires a unit which exists for itself and is common to both. This determinate unit is to be sought, as shown, only where the specific existence of the two independent measures to be compared is to be found, namely in the ratio which the exponents of the ratio of the series have to each other. But this ratio of exponents is itself a unit, existing for itself and in fact determinate only in so far as the members of the series have it as a constant ratio between them. In that way it can be their common unit. In it alone, therefore, lies the possibility of comparing the two independent measures which were assumed not to neutralize each other, but to be rather reciprocally indifferent. Each, taken by itself outside the comparison, is the unit of the ratios that it establishes with the opposite members. These are the amounts relative to this unit, and hence represent the series of exponents. But, conversely, this series is the unit for the two independent measures which are compared with each other or as quanta to each other. As such, they are themselves different amounts of their just indicated unit. But further, the measures which together with the two, or rather indefinitely many reciprocal opposing and contrasting measures, yield the series of the exponents of the ratio of these same measures are equally independent in themselves. Each is a specific something with its own relevant measure relation. To this extent, they are similarly to be taken each as a unit, so that they have a series of exponents in the two, or rather the indeterminate plurality of measures, which are first named and compared only among themselves, and these exponents are the comparative numbers of precisely these named measures. Conversely, the comparative numbers of the independent measures now taken singly are similarly the series of the exponents for the members of the first series. In this way, both sides are a series in which, first, each number is simply a unit with respect to the opposite series, in which it has its specifically determined being as a series of exponents. Second, each number is itself one of the exponents for each member of the opposite series. And third, it is a comparative number for the rest of the numbers of the series, and as such an amount which belongs to it is also as an exponent. It has its unit determined for itself in the opposite series. 3. In this relation, there is a return to the mode in which quantum was posited as existing for itself, namely as degree, as being simple and yet having the magnitude of its determinateness in a quantum that exists outside it, one which is a circle of quantum. In measure, however, this externality is not merely a quantum and a circle of quanta, but a series of numerical ratios, and it is in the entirety of these that the being determined for itself of measure lies. Just as it is the case in the being for itself of quantum as degree, the nature of the independent measure has turned into this self-externality. Its self-reference is at first an immediate relation, and by that very fact its indifference to another lies only in the quantum. Hence, its qualitative side falls in this externality, and its relating to the other becomes that which constitutes the specific determination of this independent measure. Such a determination thus consists solely in the quantitative mode of this relating, and this mode is determined just as much by the other as by the measure itself. And this other is a series of quanta, while the measure, for its part, is one such quantum. But this connection in which the two specific measures specify themselves in a third thing, the exponent, further entails that, in the exponent, the one measure has not gone over into the other, that there is not, therefore, only one negation, but that in the connection, the two measures are rather each negatively posited, and since each preserves itself in it indifferently, their negation is also negated. This, their qualitative unity, is thus an exclusive unit existing for itself. It is only in this moment of exclusion that the exponents, at first comparative numbers, first gain in them the determinateness truly specifying them reciprocally, and their difference thus becomes a qualitative nature. But such a difference has a quantitative basis. First, the independent measure relates to a plurality of its qualitatively other side only because, in this relating, it is at the same time indifferent. Second, this neutral connection is in virtue of its quantitative basis, not only alteration, but is now posited as a negation of the negation and an exclusive unit. Consequently, the affinity of an independent measure with the plurality of measures of the other side is no longer an indifferent connection, but an elective affinity. C. Elective affinity. The expression elective affinity, used here, refers to a chemical relation, as also do the preceding neutrality and affinity. For in the chemical sphere, a matter receives its specific determinateness essentially in the connection with its other. It exists concretely only as this non-indifference. Moreover, this specific connection is bound up with quantity and is at the same time not only a connection with a single other, but with a series of such non-indifferent matters standing over and against it. Combinations with this series rest on a so-called affinity with every member of the series, even though in this indifference each member excludes every other. We now have to consider this connection of opposite determinations. But it is not just in the chemical sphere that specificity is exhibited in a circle of combinations. The meaning of a single note also depends on its relation to and combination with another note and a series of other notes. The harmony or disharmony in such a circle of combinations constitutes its qualitative nature, which is at the same time based on quantitative ratios that form a series of exponents. And the ratios of two specific ratios is what each of the combined notes is within it. The single note is the keynote of a system, but at the same time also one member in the system of every other note. The harmonies are exclusive elective affinities, whose characteristic quality, however, equally dissolves again in the externality of a mere quantitative progression. Where to find, however, the principle of a measure for such affinities which, among others and against others, whether chemical or musical or whatever, are elective affinities. On this, more will be said in the following remark in connection with chemical affinity. But this is a question of a higher order which is very closely bound up with the specific nature of what is strictly qualitative and belongs to particular parts of the concrete science of nature. Inasmuch as the member of a series has its qualitative unity in the way it relates to the whole of an opposite series, the members of which differ from each other only by virtue of the quantum required for being neutralized with that member, the more specific determinateness in this manifold affinity is likewise only quantitative. In elective affinity, which is an exclusive qualitative connection, the relating escapes this quantitative difference. The next determination which offers itself is this, that in accordance with the difference in the number, hence the extensive magnitudes, of the members of one side required for the neutralization of a member in another side, the elective affinity of this member would be directed to the members of the first series with all of which it has affinity. Thus transformed, the exclusion that would thereby be established in the form of a firmer bonding against other possibilities of combination would appear in a proportionally greater intensity, in keeping with the previously demonstrated identity of the forms of extensive and intensive magnitude, inasmuch as the determinateness of magnitude is in both one and the same. However, this sudden conversion of one-sided form of extensive magnitude also into its other, the intensive form, changes nothing insofar as the nature of the fundamental determination is concerned. One which is one in the same quantum. In fact, therefore, no exclusiveness would thereby be posited, but instead of one single bonding, a combination of any number of members could just as well take place, provided that the portions of such members entering into the combinations corresponded to the required quantum proportionately to the ratios between them. But the combination, which we have also called neutralization, is not only the form of intensity. The exponent is essentially a determination of measure and, as such, exclusive. On this side of exclusive relating, numbers have lost their continuity and their tendency to combine. Their relating is one of more or less, and this acquires a negative character. And the advantage that one exponent has over another does not remain confined to the determinateness of magnitude. Also, equally present is the other side, which makes it again a matter of indifference to a moment of measure whether it receives the neutralizing quantum from several opposite moments, from each according to the determinateness that specifies it as against an other. The exclusive, negative relating is, at the same time, vulnerable to this incursion of the quantitative side. What is posited here is, thus, the sudden conversion of an indifferent, merely quantitative relating into a qualitative one, and conversely, the transition of a specifically determinate being into merely external relation, a series of relations, sometimes of a merely quantitative nature, sometimes specific relations and measures. Remark: chemical matters are the most characteristic examples of such measures, which are moments of measure and receive their determination solely in relating to other moments. Acids and alkalis, or bases, generally appear to be things which are immediately determined in themselves, but they are rather incomplete elements of bodies, components in which, in concreto, do not truly exist for themselves, but for which to exist is to sublate their isolated subsistence by binding with some other component. Further, the difference in virtue of which they are self-subsistent consists not in this immediate quality, but in the quantitative mode of relating. For that difference is not restricted to the chemical opposition of acid and alkali, or base, in general, but is specified rather in a measure of saturation. It consists in the specific way the matters that neutralize each other are quantitatively determined. This quantity determination, as defined by saturation, constitutes the qualitative nature of a matter. It makes it into what it is for itself, and the number expressing it, essentially one of several exponents for an opposite unit. A matter of this kind has a so-called affinity with another. If this connection remained of a purely qualitative nature, then, like the connection between the magnetic or the electrical poles, the one determinateness would be only the negative of the other, and the two sides would simultaneously show themselves not to be indifferent to each other. But since the connection is also of a quantitative nature, each of these matters is capable of neutralizing itself with any of the several matters, and is not restricted to the one in which it stands opposed. The relation is not just between acid and alkali, or base, but between acids and alkalis, or bases. They do, momentarily, acquire distinctive character according to one acid, For instance, none requires more of an alkali in order to achieve saturation with it than another. But the evidence that they have self-subsistent existence for themselves lies in the relation between the affinities, which is exclusive, one showing that it has a preference over another in that one acid can, as such, bond with any alkali, and conversely. Thus, the chief difference between two acids depends on whether it has a closer affinity to one base than another. That is, whether it has a so-called elective affinity with it. According to the law which has been found to govern the chemical affinities of acids and alkalis, when two neutral solutions are mixed and the result is a separation followed by two new compounds, these products are likewise neutral. It follows from this that the amounts of two alkali bases required for the saturation of an acid must be in the same ratio for the saturation of another acid. In general, granted an alkali as unit, if the series of numerical ratios in which various acids saturated is established, then this series is the same for any other alkali, except that the various alkalis are to be taken in different relative amounts, and these amounts, for their part, again form an equally stable series of exponents for each of their opposite acids, for they stand in just the same ratio as to any other. Fischer was the first to extract these series in their simplicity from the works of Richter. See his notes to the translation of Berthelot's treatise on the laws of affinity in chemistry and Berthelot's Statique Chimique. Since these works, our knowledge of the numerical ratios of mixtures of chemical elements has been greatly extended in all directions, and to want to review it here would be a digression. All the more so because this empirical, and in part also only hypothetical expansion, does not exceed the original conceptual framework. We may, however, add a few comments concerning the categories used, as well as concerning the views on chemical affinity itself and its connection with quantitative determination, and the attempt to base the affinity on specifically determined physical qualities. It is well known that Berthelot modified the broad conception of elective affinity by the concept of the effectiveness of a chemical mass. It is worth noting that this modification does not have any effect on the qualitative ratios of chemical laws of saturation, but weakens the qualitative moment of exclusive elective affinity, as such, to the point of sublating it. If two acids and one alkali react, and the one acid of which it is said that it has a greater affinity with the alkali is also present in the quantum sufficient to saturate the quantum of the base, then according to the concept of elective affinity, this is the only saturation that results. The other acid remains quite ineffective, excluded from the neutral bonding. According to the concept of the effectiveness of a chemical mass, on the contrary, each acid is effective in a proportion established on the basis of their given amounts and their saturating capacity, or so-called affinity. Berthelot's investigations have identified the more detailed circumstances under which the effectiveness of the chemical masses is sublated, and one acid, the one with stronger affinity, seems to drive out the other with the weaker affinity, and to shut out its effect, thus to behave in the sense of elective affinity. Berthelot has shown that it is circumstances, such as the strength of cohesion, the insolubility in water of the compounded salts, which condition the occurrence of this shutting out, not the qualitative nature of the agents as such, and the effects of these circumstances can in turn be sublated by other circumstances, as for instance, by temperature. With the removal of the circumstances, the effectiveness of the chemical mass proceeds unimpeded, and what appeared as a purely qualitative exclusion, an elective affinity, proves to rest on only external modifications. It is Berzelius, especially, who should be heard further on the subject, but in his textbook of chemistry, he fails to present anything original or more determined on the matter. Berthollet's views are taken up and repeated word by word, only outfitted with a metaphysics typical of uncritical reflection, and all that we are thus offered for closer inspection is just the categories of this metaphysics. That is an amazing smackdown, right? That is a shut the fuck up. That's excellent. The theory departs from experience and does both. Fabricates sense representations as such as are not given in experience itself and applies thought determinations. In either case, exposing itself to logical criticism. On this score, we want to take a look at what it says about the theory in the textbook itself. We now read there that one must imagine that in a uniformly mixed liquid, each atom of dissolved body is surrounded by an equal number of atoms of the solvent, and if several substances are jointly dissolved, they must share among them the intervening spaces between the atoms of the solvent, so that, granted a uniform mixture of the liquid, a symmetry is produced in the disposition of the atoms in such a way that all of the atoms of the individual body find themselves universally disposed with reference to the atoms of the other bodies. It could therefore be said that the solution is characterized by the symmetry in the position of the atoms and the combination by the fixed proportions. The claim is then elucidated by the example of compounds precipitated from a solution of copper chloride when sulfuric acid is added to it. But surely the example does not demonstrate that atoms exist, or that numbers of atoms of the dissolved bodies surround the atoms of the fluid, the free atoms of both acids positioning themselves around those that remain in combination with copper oxide, or that there is actually asymmetry in their position and disposition, or, for that matter, that there are intervening spaces between atoms. Least of all, that the dissolved substances share among them these intervening spaces between the atoms of the solvent. This would mean that the loose atoms take up their position where the solvent is not, for the intervening spaces in the solvent are spaces void of it. Consequently, that the dissolved substances are not in the solvent but outside it, even though they surround and besiege it, or are surrounded and besieged by it. And of course that they are not dissolved by it. One fails to see, therefore, why one would have to entertain such representations which are not evident in experience, are essentially contradictory on the face of it, and remain uncorroborated otherwise. Corroboration could come only by a consideration of these representations themselves, that is, by metaphysics, which is logic, but logic does not confirm them any more than experience does. On the contrary. And Berzelius does admit that what was also said above, that Berthollet's propositions are not opposed to the theory of determinate proportions. He, of course, adds that they are also not opposed to the views of corpuscular theory, that is, to the just mentioned images of atoms, of the filling of the intervening spaces in the solvents by the atoms of the solid bodies, and so on. But these are a baseless metaphysics that has essentially nothing to do with the propositions of saturation as such. The essential point expressed by the laws of saturation thus concerns only the amount of units themselves quantitative, not atoms, the units of a body with which the quantitative unit, equally not an atom, of another body chemically different from the first is neutralized. The difference consists in these different proportions alone. When Berzelius, then, despite the fact that his whole theory of proportions is only a determination of amounts, nevertheless speaks of degrees of affinity in explaining Berthollet's chemical mass as the sum of the degree of affinity resulting from the given quantity of the active body, whereas Berthollet is more consistent in using the expression capacité de saturation. He thereby, himself, lapses into the form of intensive magnitude. But this is the form characteristic of the so-called dynamic philosophy, which he earlier calls the speculative philosophy of certain German schools, and vehemently rejects in favor of the superb corpuscular theory. Of this dynamic philosophy, he states in the same passage that it assumes that the elements interpenetrate one another in their chemical union, and that the neutralization consists in this reciprocal interpenetration. This means nothing else than that the chemically different particles that stand opposite as aggregate merge into the simplicity of an intensive magnitude, something also attested by the diminution of volume. In the corpuscular theory, on the contrary, the chemically bonded atoms are also supposed to be retained in the intervening spaces, that is, outside each other. Juxtaposition. In this relationship, which is one of only extensive magnitude, of never-ending aggregation, degree of affinity has no meaning. Still, in the same place, when it is said that for the dynamic viewpoint of the phenomena of determinate proportions were quite an unforeseen event, the answer would be that this is only an external, historical circumstance, were it not that Richter's stoichiometric series were already known to Berthollet from Fischer's summary and were cited in the first edition of this Logic, where the nullity of the categories on which the old as well as the would-be new corpuscular theory rest is demonstrated. But Berzelius is wrong in believing that on the dynamic view, the phenomena of specific proportions would have remained forever unknown, meaning that the view is incompatible with the determinateness of proportions. The determinateness is, in all cases, only one of magnitude, whether in an extensive or an intensive form, so that, regardless of how much he stands by the first of these forms, that of aggregation, even Berzelius himself uses the representation of degrees of affinity. Since the affinity is thereby reduced to a quantitative distinction, it is sublated as elective affinity. But the moment of exclusivity present in it is traced back to circumstances, that is, to determinations that appear to be external to affinity, to cohesion, to the insolubility of compounds produced, and so on. Some comparison can be drawn here with the treatment of the effect of gravity on the moving pendulum. The pendulum necessarily comes to a state of rest because of the direct effect of gravity, yet this same effect is taken as due to the concomitant external circumstance of air resistance, thread, etc., and is ascribed to friction alone instead of gravity. Here, so far as the nature of the qualitative element present in elective affinity goes, it makes no difference whether this element appears in the form of circumstances conditioning it and is so interpreted. A new order begins with the qualitative element as such, the specifying of which is no longer just a quantitative distinction. Accordingly, although there is a well-established and precise difference between chemical affinity in a series of quantitative ratios and elective affinity as an emerging qualitative determinateness, the behavior of which in no way coincides with the order of that series, this difference has again been thrown into utter confusion by the way in which chemical behavior has, in recent times, been combined with electrical behavior, and the hope of explaining from this supposedly profounder principle the most important of relations, that of measure, has been wholly disappointed. Inasmuch as this theory in which the phenomena of electricity and of chemism are fully identified deals with things physical, and not just with ratios of magnitude, we need not consider it here in close detail. We only have to bring it up inasmuch as it confuses the principle for differentiating the determinations of magnitude. The theory deserves to be called shallow, for shallowness consists in taking different things as identical by omitting their difference. As for affinity, since the theory identifies chemical with electrical processes, these last including the phenomena of fire and light, it is reduced to the neutralization of opposite electricities. It is almost comical to find the identification itself of electricity and chemism stated as follows. The electrical phenomena indeed explain the effect of bodies at a greater or lesser distance, their attraction before union, that is, a behavior which is not yet chemical, as well as the fire resulting from this union, but they yield no information regarding what causes the unions of bodies which persist with so great a strength after the removal of the state of electrical polarization. That is, this theory informs us that electricity is the cause of a chemical behavior, but gives us no information regarding what is chemical in the chemical process. The chemical difference being reduced to the opposition between positive and negative electricity. The difference in affinity between the agents falling on either side is determined as the order of the two series of electropositive and electronegative bodies. What is already being overlooked in this overall identification of electricity and chemism is that electricity in general, and its neutralization, is a transient phenomenon, one that remains external to the quality of bodies, whereas chemical action, and especially its neutralization, is directed to and alters the whole qualitative nature of the bodies. Equally transient in electricity is its opposition of positive and negative, so unstable that it is subject to the slightest external circumstances and can in no way be compared to the determinateness and stability of the opposition of acids to metals, for example, and so forth. All right, here's something that I can actually talk about. Right, there's a lot of math in here, and I'm not a polymath, and while all of this does make sense, I don't have the capacity to explain it in a different way, and so I haven't bothered, right? We talk about the things we can, and we don't about the things we don't. This is a fundamental misunderstanding of what is going on. Chemical change is enabled by ionic bonds, right? The positive and negative charges of the individual atom. That is a truth that we have discovered since this book was written. What was not understood was ionization, the process by which an electron or a chemical element may pick up or lose electrons, right? That results in a more positive charge or a more negative charge, and that in turn increases the reactivity to specific stimuli, right? Whatever it is that if you have an acid and a base and you mix them together, they react, including where it had the question behind the fire, it releases heat. All chemical change is going to release heat because it is an activation of plasma. Now, that is a little bit of a hard concept for some people, and we have not unpacked that at all in this study that I remember, but plasma is the entirety of everything, right? Now, I look at it in metaphysical terms. I believe in a God. Now, that is not the anthropomorphized God of Christianity or Judaism or Muhammad or any of that. It is, I believe that the God is infinite. Go back to the very first part of this lesson and learn the difference between infinite and finite, right? If you are putting any limitation upon the creative power, you are making it finite. It exists beyond any definition that you can place upon it, but I do believe that it exists. When you place that finite definition upon the infinite, it is differentiated. It goes from being God, which is infinite, into the spirit, which is finite, right? Same thing, just one is defined, the other is not. When you define spirit, it is in the moment of the beginning, right? Where everything starts, but everything is in stasis until there is motion. That is the spirit inactive. When the spirit is active, it is moving through time. Any change whatsoever is a movement of the spirit. Now, the spirit is technically every single atom in existence. Every one of them, and all of the space between them, as minuscule as that is, all of that is the spirit. The differentiation is easily recognizable in lightning. Lightning is the ionization of the atmosphere and producing a chemical change. Plasma exists around you right now. You are completely encapsulated in the plasma, and in addition to that, you are created out of that plasma. Now, the plasma around you is inactive. It has the potential to change, but is not changing quite yet. that potential can be realized into actuality, right? But that moment of actualization is the logos in motion. It is literally the spirit defined in motion. And so what you see happen when lightning is that the plasma in between the space of the cloud and the ground is ionized, right? There is a static charge that develops either in the cloud or in the ground. It happens both ways. But there is a static buildup, and then there is a path of least resistance that is achieved. The wind blows in exactly the right way. The area lines up perfectly, and there is change initiated from the sky to the ground or the ground to the sky. Again, it goes both ways. And that process is you visually able to see chemical change taking place. Every bit of the space that lightning bolt occupies is in fact atoms. Those atoms, some of them are in combination with each other. We will use one example. It is a relatively easy one. Water. There is hydrogen times 2 and an oxygen times 1, and they are molecularly bonded and floating around in the air. When lightning comes down, it ionizes and separates that water into the primitive elements. It becomes now, instead of H2O, it becomes HHO, which is then able to form into other things. One of the other things that forms regularly during the ionization process of lightning is O3. Right? The hydrogen is separated off. The oxygen forms a bond between itself times 3. That is called ozone. That is the part that sits on top of our atmosphere between the stratosphere and the lithosphere and reflects radiation back into the space. That process of change is you quite literally seeing ionization happening. You are witnessing molecular bonds being broken. The external light that is given is that fire that had the question mark behind it. It is the release of potential energy, the logos in action. Now you are the exact same as that lightning to a different degree. You can be seen. I'm assuming. I can be seen. You're seeing me right now. My skin is undergoing molecular changes right now. My heart is pumping out blood. That blood is taking oxygen to my body and is dispersing it into my cells. That action produces what you see. That is the same in you. It is the same in lightning. When you die and decompose and the elements go back to where they were, that is a slow process, but it is reversing the ionization process in you. I believe that is as clear as I can possibly make that concept. If it is confusing to you, let me know it down below. But what we see here is not understanding there is no separation between chemical affinity and electrical affinity. Chemical affinity takes place because of electrical affinity. The understanding in the 1800s was not quite where it is today. Back to the text. The volatility that can occur in chemical behavior because of extremely violent influences, e.g. because of raised temperature, is not comparable to the superficiality of electrical opposition. And the further difference inside the series of each of the two sides between a more or less positive or a more or less negative disposition is just as entirely uncertain as it is entirely unconfirmed. Yet, it is from these series of bodies, in accordance with their electrical dispositions, that we can expect the electrochemical system which is best suited to yield an idea of chemistry. But how these series, which are only alleged here, are in fact constituted, regarding this point, it is added on in page 67, that such is approximately the order of these bodies, but so little research has been done into this matter that nothing altogether certain can yet be ascertained regarding this relative order. Both the numerical ratios, first made by Richter, of the series of affinities, as well as the highly interesting reduction established by Berzelius of the combination of the two bodies to the simplicity of a few quantitative ratios are totally independent of that supposed electrochemical concoction. If the experimental procedure has been the right guiding star in the theory of proportions and the extension it has won on all sides since Richter, then all the more does the mixture of these great discoveries contrast with the wasteland of the so-called corpuscular theory, which lies outside the path of experience. Only this forsaking, at the start, of the principle of experience could have motivated taking up again the notion, already advanced earlier by Ritter, of establishing fixed orders of electropositive and electronegative bodies, which would have the chemical meaning at the same time. The assumption of a basis for chemical affinity in the opposition of electropositive and electronegative bodies, even if such an opposition had more to recommend it factually than it does, reveals its nullity even experimentally. And this then leads to further inconsistency. It is admitted on page 73 that two so-called electronegative bodies, such as sulfur and oxygen, combined in a much more intimate way than, for instance, oxygen and copper, although the latter is electropositive. The basis for the affinity founded in the general opposition of negative and positive electricity must here give way, therefore, to a mere more or less within one and the same series of electrical determinateness. From this, it is concluded that the affinity of bodies does not therefore depend solely upon their specific unipolarity. It does not matter with which hypothesis this determination is associated. It applies here only for the either of the positive and the or of the negative. The affinity must in essence be derived from the intensity of their polarity in general. That is close to true. Here the consideration of affinity thus broaches the relation of elective affinity, which is our principal interest. Let's see now how it fares. It is immediately granted that the degree of this polarity, if it does not exist in our imagination, seems not to be a constant quantity, but to depend rather very much on temperature. Accordingly, the upshot is not only that every chemical effect is fundamentally an electrical phenomenon, but also that what seems to be the effect of the so-called elective affinity is produced only by an electrical polarity, which in certain bodies is found to be stronger than in others. The conclusion, then, after so many twists and turns of hypotheses, is that we have not gone past the category of greater intensity, which is the same formal determination as elective affinity in general, and since the latter is made to rest on a greater intensity of electrical polarity, it does not take us a whit closer to a physical basis. But even what is here supposed to be determined as a greater specific intensity is later reduced to just the already cited modifications which Berthollet demonstrated. Berzelius's merit and fame, because of his theory of proportions, which has been extended to all chemical relations, ought not by themselves to stand in the way of criticizing the poverty of the theory. But a more pressing reason for doing so must be the circumstance that the merit which one side of science deserves, such as Newton's, normally lends authority to a whole unfounded structure of bad categories associated with it, and it is precisely this metaphysics which is proclaimed and circulated with the greatest pretension. Besides the forms of measure relation connected with chemical and effective affinity, others could also be considered with respect to quantities which are qualitatively specified into a system. Chemical bodies form a system of relations with respect to saturation. The saturation itself rests on the determinate proportion in which the two reciprocal amounts bind together, each with a particular material concrete existence as against the other. But there are also measure relations, the moments of which are indivisible and cannot be displayed as existing each on its own, each different from the other. These are what we called earlier the immediate independent measures and are attested in the specific weights of the bodies. They are inside the bodies a ratio of weight to volume. The exponent of the ratio, which defines the difference between one specific weight and another, is a determinate quantum only by way of comparison, and this is a relation which is external to the bodies, founded on an external reflection and not on a body's typical qualitative way of relating to an opposite concrete existence. The task would be to make out the exponents of the ratios of the series of specific gravities as a system governed by a rule, specifying an otherwise merely arithmetical plurality as a series of harmonic nodes. The same demand would apply to the discovery of the series of chemical affinities already mentioned, but science still has far to go before reaching this goal, just as far as would be required to collect the numbers of the distances of the planets within the solar system into a system of measure. Although the specific gravities do not seem at first to stand in any qualitative relation to one another, they nonetheless likewise enter into a qualitative connection. When bodies bond chemically, even if only as amalgams or sensemates, there is likewise evidence of a neutralization of specific gravities. We earlier called attention to the phenomena that the volume of a mixture, even of materials which truly remain chemically indifferent to each other, is not the same as the sum of the volumes prior to the mixture. In the mixture, the quantum of the specific gravity with which the materials entered into connection is reciprocally modified, and this is evidence that they relate to each other qualitatively. Here, the quantum of the specific gravities is expressed not merely as a fixed comparative number, but as a numerical ratio, which is variable. And the exponents of the mixtures yield a series of measures which are governed by some other principles than numerical ratios of the specific gravities bonded together. The exponents of these ratios are not exclusive determinations of measure. Their progression is continuous, but hold within it a specifying law, which is different from the reflectively formal progression of the ratios, in which the amounts are combined and makes the former progression incommensurable with the latter. B. Nodal lines of measure relations. The last determination of the measure relation was that, as specific, it is exclusive. Exclusiveness accrues to neutrality as a negative unit of the distinct moments. For this unity, existing for itself, for this elective affinity, no further principle has become available specifying its connection with other neutralities. The specification resides only in the quantitative determination of affinity in general, according to which it is specific amounts that neutralize themselves and, consequently, stand opposed to other relative elective affinities of their moments. But further, because the basic determination is quantitative, the exclusive elective affinity continues also into these opposite neutralities. And this continuity is not just an external comparative connection of the different ratios of neutralities, but the neutrality, as such, has an element of separability in it. For it is as self-subsisting somethings that the moments from whose union it has come to be enter into connection with one or the other of the opposite series. They enter into the connection indifferently, even though they combine in different specific determinate amounts. This measure, internally based on such a relation, is, for this reason, affected by an indifference of its own. It is something which is external within and alterable in its reference to itself. This self-reference to the measure relation differs from the externality and alterability which belongs to its quantitative side. In contrast to these, its self-reference is an existent qualitative foundation, a permanent material substrate which, since it is also the continuity of the measure with itself in its externality, would have to contain in its quality the said principle of specification of this externality. Now, in more developed forms, as external to itself in its being for itself, the exclusive measure repels itself from itself and posits itself both as another merely quantitative relation and as another relation which is as such at the same time another measure. It is determined as in itself a specifying unity which produces measure relations within itself. These relations differ from affinities of the kind mentioned above, in which an independent measure relates itself to independent measures of another quality, and a series of these. They occur in one and the same substrate, within the same moments of the neutrality. The self-repelling measure takes on the determination of other, only qualitatively diverse relations, and these relations likewise form affinities and measures, alternating with those that remain only quantitative diversities. They form, in this way, a nodal line of measures on a scale of more and less. Here we have a measure relation, a self-subsistent reality qualitatively distinguished from others. Such a being for itself, since it essentially is at the same time a relation of quanta, is open to externality and quantitative alteration. It has a margin within which it remains indifferent to this alteration and does not alter its quality. But there comes a point in the quantitative alteration at which this quality alters, and the quantum shows itself to be specifying, so that the altered quantitative relation is suddenly turned into a measure and thereby into a new quality, a new something. The relation that has now replaced the first is determined by the latter, both because of the qualitative sameness of the moments which are in affinity and because of the quantitative continuity. But since the distinction falls on the side of this quantitative moment, the new something stands indifferently related to the preceding one. The difference between the two is the external one of the quantum. The new something has not, therefore, emerged out from the preceding one. It has emerged, rather, immediately from itself, that is, from the internal specifying unity which has not yet entered into existence. The new quality, or the new something, is subjected to the same progression of alteration, and so on into infinity. Inasmuch as the advance from quality proceeds into the steady continuity of quantity, the ratios approaching the one qualifying point are distinguished, quantitatively considered, by a more or less. In this respect, the alteration is a gradual one, but the gradualness concerns merely the externality of the alteration, not its qualitative moment. The preceding quantitative relation, though infinitely near the succeeding one, is still another qualitative existence. From the qualitative side, therefore, the gradual, merely quantitative progression, which has no limits in itself, is absolutely interrupted, and since in its merely quantitative connection, the newly emerging quality is, with respect to the vanishing one, an indeterminate other, one which is indifferent to it. The transition is a leap. The two are posited as wholly external to each other. It is a favorite practice to try to make an alteration conceptually comprehensible by the gradualness of the transition leading up to it. But gradualness is rather alteration precisely as merely indifferent, the opposite of a qualitative alteration. Rather, in gradualness, the connecting link between two realities, be they states or self-subsistent things, is sublated. What is posited is that neither reality is the limit of the others, but that each is absolutely external to the other. Thus, the very point necessary for the conceptual comprehension of the alteration is missed, although little enough is required for that purpose. Remark. The system of natural numbers already exhibits a nodal line of qualitative moments which issue in a merely external progression. In one respect, this progression is a merely quantitative running back and forth, a constant adding and subtracting, each number standing in the same arithmetical relation to the one preceding or following it as this last stands to the one preceding or following it in turn, and so on. But the numbers that thus arise also stand to the others that would either precede or follow them in some specific relation, whether as a multiple of one of them expressed in the form of a whole number or as a power or root. And the quantitatively measured scale of musical relations, a quantum, gives rise to a relation of harmony in the progression of notes, without that quantum having on the scale any other relation to the preceding and the succeeding ones than these have in turn to those preceding and following them. The notes that follow seem increasingly to recede from the keynote, or numbers, to become just other numbers in their arithmetical advance. Yet, a turning back suddenly breaks out, a surprising accord for which there was no qualitative preparation in what immediately went before, but which appears rather to be an actio in distance, a connecting reference to something far removed. The succession of merely indifferent relations which neither alter the preceding specific reality, nor otherwise form any such reality, is suddenly interrupted, and while from the standpoint of quantity the succession proceeds in the same manner, a specific relation breaks in through a leap. Nodes and leaps of this kind occur in chemical combinations as the proportions in the mixtures are progressively altered. At certain points on the scale of mixtures, two materials yield products that exhibit particular qualities. These products do not differ by a mere more or less, nor are they already present at the proportions closest to their nodal points, perhaps in only a weaker degree. The bonding, rather, occurs at just these points. For instance, oxygen and nitrogen yield in combination different oxides of nitrogen in different nitric acids, exhibiting essentially different qualities, only at specific mixture proportions, without any specific bonding occurring in between. Metal oxides, e.g. the lead oxides, are formed at certain quantitative points of oxidation and are distinguished by colors and other qualities. They do not pass into one another gradually. The proportions lying in between those nodal points yield nothing neutral, no specific existence. A combination which specifically depends on a measure relation occurs without having passed through the in-between stages and displaying qualities characteristically its own. Or, take water. As it alters in temperature, it does not become just more or less warm, but passes through the states of solid, liquid, and vapor, and these different states do not occur gradually, but, on the contrary, even the otherwise merely gradual increase in temperature is interrupted and inhibited at these points. The interruption is another state, is a leap. Every birth and every death, far from being a protracted gradualness, is rather its breaking off and a leap from quantitative into qualitative alteration. Natura non facit saltum, as the saying goes, and ordinary thinking, when confronted by a coming to be or a passing away, believes that it has comprehended it conceptually by representing it, as we said, as a gradual emerging or vanishing. But we have seen that the alteration of being, in general, are not only the passing over of a magnitude into another magnitude, but the transition from the qualitative into the quantitative and contrariwise, a becoming other that interrupts gradualness and stands over against the preceding existence as something qualitatively other. Water, in cooling, does not become hard a bit at a time, as if it became first like a porridge and then would gradually harden into the consistency of ice, but is hard all at once. It can persist in a fluid state even at freezing temperature if it stands still, but then the least disturbance brings it to the state of a solid. The belief that coming to be is gradual is based on imagining what comes to be is already present to the senses, or is in principle actual, only so small that it still escapes perception, and so too for the gradual vanishing of something. What is imagined is that the non-being, or the other, which is to take its place, is likewise there, but is not yet detectable. Is there, not in the sense that this other is in itself contained in the present other, but that it exists there, only undetectably. In this way, coming to be and vanishing are in principle done away with, or the existence which something has in principle, still undisplayed, before actually existing, is transformed into a smallness of external existence, and the essential conceptual difference into a difference of mere magnitude. Explaining coming to be and vanishing from the gradualness of alteration suffers from the tediousness typical of any tautology. The coming to be and the vanishing are presupposed as ready-made beforehand, and the alteration is reduced to the mere mutation of an external difference. I lost my spot. Qualitative transition from something into its other and general opposite. I missed that. Where did external difference, and in this way the change becomes in fact only a tautology. The difficulty confronting an intellect intent on this kind of explanation lies in the qualitative transition from a something into its other in general and into its opposite, a difficulty which the intellect meets by pretending that identity and alteration are the indifferent external identity and alteration of the quantitative sphere. In moral matters, inasmuch as they are treated in the sphere of being, there occurs the same transition of the quantitative into the qualitative. Different qualities appear to be based on a difference of magnitude. It is by a more and less that the measure of frivolous delinquents is overstepped, and something entirely different comes irresistibly to the scene, namely, crime, which makes right into wrong and virtue into vice. Thus, states, too, acquire through their quantitative difference, other things being assumed equal, a different qualitative character. The laws and the constitution of a state alter in character whenever its territory and the number of its citizens expand. A state has its own measure of magnitude, and if this measure is trespassed, it irresistibly disintegrates internally under the same constitution which, when with just different proportions, was the source of its good fortune and strength. C. The measureless. The exclusive measure, even in its realized being for itself, remains affected by the moment of quantitative existence and is therefore susceptible to the movement up and down the quantum scale of varying ratios. Something, or a quality, based on such a ratio is driven beyond itself into the measureless, collapsing under the mere mutation of its magnitude. Magnitude is that constitutional aspect wherein existence can be caught up in an apparently harmless entanglement and be destroyed by it. The abstract measureless is the quantum in general, inasmuch as it lacks internal order and is only indifferent determinateness which does not alter measure. In the nodal lines of measures, this determinateness is at the same time posited as specifying. The abstract measureless sublates itself into qualitative determinateness. The new measure relation into which the original passes over is measureless with respect to the latter, but in it equally is a quality that exists for itself. What is thus posited is the alternation of specific existences with one another, and equally of them with relations that still remain merely quantitative, an alteration ad infinitum. Therefore, present in this transition is both the negation of the specific relations and the negation of the quantitative progression. This is the infinite existing for itself. In the sphere of existence, the qualitative infinite was the irruption of the infinite into the finite, the immediate transition and vanishing of the this here into its beyond there. In contrast to it, the quantitative infinite is, in its very determinateness, the continuity of quantum, its continuing beyond itself. The qualitatively finite becomes infinite. The quantitatively infinite is beyond in it. It points beyond itself. But this infinite of the specification of measure posits both the qualitative and the quantitative as each sublating itself into the other. It thereby posits their first immediate unity, which is measure in general, as returned into itself and consequently as itself posited. The transition of the qualitative of one specific concrete existence into another is such that what happens is only an alteration of magnitude determinateness. The alteration of the qualitative as such into the qualitative is thus posited as an external and indifferent alteration, as a coming together with itself. The quantitative, for its part, sublates itself by suddenly turning into the qualitative, that is, a being which is determined in and for itself. This unity, which thus constitutes in itself, in its alternating measures, as the self-subsistent matter that truly persists, the fact. What we have here is one and the same substantial matter which is posited as the perennial substrate of its differentiations. This detaching of being from its determinateness already begins in quantum in general. Something is greatly indifferently as against the determinateness it has. In measure, the persisting matter is itself already in itself the unity of the qualitative and the quantitative, the two moments into which the general sphere of being is distinguished, each as the beyond of the other. In this way, the perennial substrate begins to possess in it the determination of an existent infinity. Beta. This self-sameness of the substrate is posited in that the qualitative independent measures into which the determining unit is dispersed consist of only quantitative differences, so that the substrate persists while being internally distinguished. Kappa. In the infinite progression of the nodal series, there is posited the continuation of the qualitative into the quantitative advance, as into indifferent alteration. But, equally too, there is posited the negation of the qualitative contained in the progression and, consequently, at the same time, of the merely quantitative externality. The quantitative pointing beyond itself to another, which is itself quantitative, perishes with the emergence of a measure relation, of a quality, and the qualitative transition is sublated in the very fact that the new quality is itself only a quantitative relation. This reciprocal transition into the other of the qualitative and the quantitative moments occurs on the basis of their unity, and the meaning of this process is only the existence, which is the demonstration or the positing that such a substrate does underlie the process and is the unity of its moments. In the series of independent measure relations, the one-sided members of the series are immediate qualitative somethings, specific gravities or chemical materials, bases or alkalis, acids, for instance, and their neutralizations, by which we must understand here also the combinations of materials of different specific gravities, are in turn self-subsistent and themselves exclusive measure relations, mutually indifferent totalities existing for themselves. Such relations are now determined only as nodes of one and the same substrate. The measures and the self-subsistent forms posited with them are consequently demoted to states. Alteration is only the mutation of a state, and that which passes over is posited as remaining the same in the mutation. In reviewing the progressive determination which measure has gone through, the moments of the progression can be summed up as follows. Measure is at first itself the immediate unity of quality and quantity in the form of a common quantum, which is, however, specific. As a determinateness of quantity which does not refer to another but refers to itself, measure is thus essentially a ratio. Consequently, it also holds its moments as sublated and unseparated in itself. As is always the case in a concept, the difference in the ratio is such that each of its moments is itself the unity of the qualitative and the quantitative moment. The difference is thus real, and it yields a multitude of measure relations which, as formal totalities, are each self-subsistent in themselves. The series, which form the two sides of these ratios, are, for each single member, the same constant ordering by which the member, as belonging to the one side, relates itself to the whole series standing opposite. This ordering, although a mere order, is still wholly external unity, demonstrates itself to be as the eminently specifying unity of a measure which has a determinate being for itself, distinguished from its specifications, but the specifying principle is not yet the free concept, which alone gives its differences an eminent determination. The principle is at first rather only a substrat, a matter for whose differences, in order that they be totalities, that is, that they should have in themselves the nature of their stable, self-equal substrate, there is only available the external, quantitative determination, which shows itself at the same time to be a qualitative differentiation. In this self-unity of the substrate, the determination of measure is a sublated determination, its quality and external state determined by quantum. This course is equally the progressive determination of measure and its demotion to a moment. And that is going to bring us to the end of real measure. Hopefully I brought a little bit of enlightenment and not too much confusion to a somewhat difficult topic. I understand I hold some unconventional beliefs, and I have a tendency to step on toes when I relay those. It is not intentional, but it is not something I apologize for. Once again, I don't have a whole lot to add to this. I had the one little part where I actually had a little bit of knowledge. All of these concepts are, to me, not necessarily self-evident, but being pointed out like this, they make sense, right? The relationship between yourself and the change is going to be immediate, even if it is gradual, right? You can take water and you place it in a controlled environment of 32 degrees, and when the entire thing reaches 32 degrees, ice begins to form. It's not necessarily an immediate reaction, although it is an immediate reaction. Even the process of turning a single ice cube into an ice cube from water takes an amount of time. That amount of time is gradual, but it is sudden at the same time. And I understand what they're saying, right? It is a gradual bring up to the point of, but that point of becomes a snapping point where it becomes, right? It goes all the way up to that one point, and then it changes, and it is something different. It is the same in chemical affinity. It is the same in ionization. Up until the moment of change, the change doesn't exist. But once the change is enacted, the change is immediate. That makes sense to me. I don't know that I can explain it in a better way. The part about the spirit and plasma and all of that, I've explained that a lot. If you're unaware, I've got a whole bunch of playlists up here where I talk about it. But one of those, well, I don't normally link that one, but I have a members-only playlist where I read through my book, and one of the things that we talk about in my book was that particular relationship. So if you are interested, check it out. Where am I at? If you like what I'm doing over here, let me know down below. Give me a like, a share, a follow. Throw me a comment if you agree or disagree with anything that was stated. Put it in the box. If it remains respectful, it gets to remain up. If there is another work you would like to see me read or discuss, drop that in the box as well. If you really like what I'm doing over here, hit me with that super thanks. Check out a membership or buy a copy of my book. All of them will be greatly appreciated. To the crew, thanks for hanging out. I appreciate every single minute that you are here with me, and I am praying for you every single day. Until next time, I love you. God loves you. You are perfect, whole, and complete just the way that you are. And this has been Pit Steak. Peace.